waiting for your lecture.
It's all fundamentals only, not practical orientation this time.
Those fundamentals are required for our students. Because they have good fundamentals, definitely they will build a good building later.
This is only an overview, because this is a vast subject which we cannot cover in 1 hour.
Yes, just the introspection.
Yes.
Sir, Ramu sir.
Yes, sir.
Sir, can you? We will share the screen later, sir. We shall have a photo while starting the session. Okay. You also switch on the video, sir. Please.
Okay, fine. Just give me 1 second.
Please switch on your video, sir. Okay. Okay, sir. We will start the program, sir.
Yes, sir. Please start the program, sir.
So, good evening to all participants. On the occasion of 138th birth anniversary celebrations of Sri Srinivasa Ramanujan, our department is conducting a 1-week online international workshop on mathematics, bridging ideas and innovations, MBII 2025, from 15th to 20th December 2025. On the first day, Dr. K. Lavanya Madam, Assistant Professor, Department of Computer Science, Acharya Nagarjuna University, Guntur, delivered a talk on a mathematical key for understanding quantum computing in AI era. On the second day, that is 16th December 2025, Dr. L. Jagannathan sir, Professor, School of Computer Science and Engineering, Vellore Institute of Technology, Chennai, delivered a talk on mathematics of transformers. On the third day, that is 17th December 2025, Dr. M.A.S. Srinivas Garu, Professor Emeritus, Department of Mathematics, JNTU, Hyderabad, delivered a talk on role of mathematics in technology. On the fourth day, that is 18th December 2025, Sri NVRD Kumar Garu, Senior Faculty, Department of General Education, Harjan University College, Emirate of Asman, United Arab Emirates, delivered a talk on mathematics behind data science, the secret engine of today's tech innovations. On the yesterday, Dr. P. Nagarani Madam, Associate Professor, Department of Mathematics, the University of West Indies, Jamaica, West Indies, delivered a talk on differential equations for engineers. Around 500 participants attended yesterday's session. Thank you one and all for your valuable participation in yesterday's session. Today is the 6th day in our 1-week online international workshop. Today's speaker is Dr. T. Ramalingeswara Garu, Senior Data Scientist, Advanced Quartz Analytics, Aqua, BFSI A&I, Gachibowli, Hyderabad. Okay. Now I request one of our staff organizers, Srimati M. Anita Madam, to present the profound profile of Dr. T. Ramalingeswara Garu. Madam, please.
Good evening all. Welcome you all to a 1-week online international workshop on mathematics, bridging ideas and innovations. It's my privilege to introduce today's resource person, Dr. T. Ramalingeswara Garu. Dr. T. Ramalingeswara sir is a distinguished professional serving as a senior researcher and senior data scientist at BFSI AQA, a division of analytics and insights within Tata Consultancy Services, located in Hyderabad, India. With a strong academic and research background, he did his PhD in large-scale graph analytics from the prestigious Indian Institute of Technology, IIT, Kharagpur in 2020. Before pursuing his doctoral studies, Dr. T. Ramalingeswara sir completed his MTech in computer science and data processing from the same institution, IIT Kharagpur, further solidifying his expertise in computational sciences. Dr. T. Ramalingeswara sir has made significant contribution to his field. publishing scholarly articles in esteemed journals such as Knowledge and Information Systems and a Journal of Supercomputing. His work has also been featured in various international conferences, showcasing his commitment to advancing research in data science and analytics. His primary research interests lie in the areas of large scale graph processing, graph data science, unsupervised machine learning, artificial intelligence, and big data analytics, with a keen focus on developing innovative methodologies and tools. Dr. T. Ramalingeshwara Sir's research addresses complex problems in data science, offering a practical and scalable solutions. With his soft spoken demeanor, unyielding dedication, and forward thinking approach, Dr. T. Ramalingeshwara Sir continues to inspire his peers and contribute significantly to the fields of data science and analytics. Thank you.
Thank you, Anita Madam, for your nice introduction about Dr. T. Ramalingeshwara Garu. Now I hand over the session to Ramalingeshwara sir. Sir, please, sir.
Thank you, sir. Thank you, madam, for introducing me. Thanks to Professor Narasimha for giving me the opportunity for this talk, because this is our mother institution. But somehow I could not focus. I could not join for more programs, but I'm happy that you have given opportunity for this 138 birthday celebrations of Srinivasa Ramanujan. So I remember that, so we used to celebrate Ramanujan Day even in when we studied MSc Mathematics 97 to 99. So in our college. So that was, I mean, great memories for us. Okay. So let me share my screen. So we'll go to the presentation. Can you see my screen?
Yes, sir.
Sir, clear, sir. Clear.
Okay. So today's this is a theoretical topic which I want to present the basic fundamentals. People are using ChatGPT, Perplexity, and so many thousands of tools are there nowadays. So basically, this I want to give some small concepts where mathematics is playing a critical role. So all these ChatGPT and Google PageRank, so these are working on based on matrix multiplication and eigenvectors and eigenvalues, which people don't know to the real world. So that's, I mean, some small basics how all these ChatGPT or DAL-E, so Google Gemini, so all these are working based on some small kind of matrix multiplications and some other mechanism known as definition mechanism. I think Jagannath sir covered something, but this is a different view, and that is a different view which I observed that lecture also. So if you see in previous days, we have the technology, big data technology like Apache Hadoop and Apache Spark. So why we need big data system means, so many people are working now in industry and so many employees are there. Lots of data is generating and storing that data, huge data in gigabytes is a question mark for us. How we need to such a huge data in data warehouses. So earlier we have database systems. After that we have data warehouse systems. Now people are using data lakes. So more advanced technology is data lakes. First we have databases, then we have data warehouses. Now we have data lakes. So the biggest challenging task is how we need to store the data, then how we need to pull the data according to our necessities, how we will process the data. So this is the goal in front of the people. So then to process the data, they have lots of technologies. We have earlier we have the Hadoop MapReduce, which depends on mappers and I mean, based on key value pairs. so mappers and reducer functions. So now after that we have the Apache Spark, then Apache Flink. These are the processing systems. Means if you store the data somewhere, how you will pull the data. We need some engine. That engine is nothing but Apache Spark, Apache Hadoop. These are the engines to pull the data where you store the data in a data warehouse or in data lake. We need to pull that data. So for that, we need engines. Those engines are nothing but computational engines, which are nothing but Apache Hadoop and Apache Spark. And another one is Apache Flink. So if you see here in our big data system, how it will work. So data collection is the biggest task for us. Suppose we are purchasing some, let us say, some online items, let us say computers or clothes or shoes in an online site, e-commerce site like Amazon. So when you buy something, so whatever you click the items, those data will be stored in the database. And whatever you will purchase, that information is also available with them. So that data storage is the biggest task here. So that is nothing but data capture or data acquisition, or also called as data collection. So we have different ways. Whenever there are human generated machines, for example, so many scanners are there. So those are human generated machines. Okay, so then sensors will capture the data. So like that, we can store the data in a particular data warehouse or database or data lakes. So data sources, these are the data sources. Basically, when we are uh, capturing the data in e-commerce sites through, or when you go for a shopping mall, through sensors, we are capturing the data. If your car is passing through a particular toll gate, so there also we have the data capture facility. All these are comes under the data sources. Okay, so once if you collect the data, how you will manage the data? Means I have the lots of data. How you will manage, how you will store properly, and how you will process, and how you will retrieve the data. Okay, so for that we have the file system known as distributed file system. Means let us have some couple of computers. Let us say 100 gigabytes data is there. Store 30 GB in one system, another 30 in another system, another 30 GB is another file system. That is why this is called as distributed file systems. There are so many distributed file systems. Every company, they have made their own file systems. Initially, we have Hadoop distributed file system. Before that, we have Google file system. Then each company, they have developed their own file systems. For example, Google has Google file system. Apache Hadoop has Hadoop file distributed file system. This Facebook and other guys has Haystack distributed file system. Like there are so many distributed file systems, but standard one is Hadoop HDFS, known as Hadoop distributed file system. Okay, so we have the data, structured data, like storing the data using key value pairs. So only we have homogeneous kind of data, means the data either names or numbers. Okay, so these whenever you have the categorical variables, some boards or some numeric values. So all these are a kind of structured data. When you have the image data or video data, or something like links, web links data, that is called as semi-structured data. When you have the combination of all this data, so then processing the data is a very difficult task. For that purpose, people have developed NoSQL databases. So NoSQL databases means not only SQL, but it also handles unstructured data. It also handles how to store and retrieve the unstructured data in the databases. Okay, so then we have the next one is data processing. First one is data collection. Second one is the data management, means how you are storing in terms of distributed file systems, how you are retrieving in terms of NoSQL databases. Then second one is the processing the data. Computing you need to do some operation. Let us say I want to retrieve collection of all purchases done by Mr. Ram. So I need to apply some operation. That is nothing but computational process. So for data processing, we have computational frameworks like what I said, Hadoop MapReduce, then Apache Spark, Apache Flink. These are called as computational frameworks. Now, if you see Google, Amazon cloud system is there. Similarly, Microsoft Azure cloud system is there. Everybody is depending on the computational engine, which is known as Apache Spark. Okay, then once if you compute, if you do some operations, if you get the data, whatever required, how many things I purchased in the month of December or in the month of November. So then what are my purchases? At what time I bought some items? What are the timestamps? So all those information, if I get, then immediately I need to do some analysis. Let us say what is the analysis means. In the month of November, how many people purchased shoes between the age 30 to 40? So I want to do some analysis and I want to see visually, not in the terms of table, something like. Visually, I need to see the things. Then for that purpose, we need to have some analysis, which is known as data analysis, and we will apply some data analytics kind of algorithms we will apply. So like breadth first search, depth first search, or community detection algorithms, how many male people, how many female people purchased, or from which city we have the huge number of purchases. Like that, we'll get the information. For that, we'll apply some data analytics kind of things. So then finally, we need to see visually. So there are lots of thousands of visualization tools are there. So in my last lecture in BEC in the previous year, for 137 birthday celebrations, I explained those visualization kind of things. So at the time, we have the graph data science using visualization techniques that we have discussed these concepts. Okay, so now coming to our large language models, this is one part of field known as natural language processing. This is a subfield of machine learning. So it's based on the information available in the internet, or whatever we are feeding to the system. So how a machine can generate the new kind of things from the existing texts. So this kind of things will involve several steps here. If you see here, so NLP is a broad field where we particularly focus on enabling computers to understand, to interpret and generate new information. So this is known as NLP task. So if you see the subtasks in NLP, these are some of the subtasks. One is sentiment analysis. Means, for example, if I'm participating in a particular election, so there will be opinion polling, or opinion mining will be there. So this kind of things can be done by using the NLP tasks. Okay, then named entity recognition. So if you give some text, let us say 1-page information, then we need to identify what is the subject, what is the object, and what is the verb. Okay, so for example, Rama killed Ravana. So who is the subject, who is the object, and what is the verb here? So such kind of things we can get using named entity recognition for a given text. The text may be anything. It may be 1 page or 1 paragraph, or it may be in gigabytes. Then linguistic analysis and texts. So some kind of semantics we need to apply here. So in linguistic analysis. Then building knowledge graphs. This is one good area. So where mathematician can focus building knowledge graphs using NLP techniques. Okay, so there will be slight modifications between the pipelines of machine learning and natural language processing pipeline. So first point is data collection, then cleaning the data. So when we have some missing values or some kind of unnecessary operators will be there in the data that we need to remove. That are the part of data cleaning, and then data pre-processing. So we need to. This is called as data completeness. Any missing rows are there, any duplication rows are there. So we need to do the data pre-processing here. So then we will do exploratory data analysis. we will describe entire the data set details here. What are the features available? And so we'll take some kind of statistics here about the data here. So then feature engineering. What are the features available here in the data? Okay, so features means, let us say if I am talking about timestamps, Ram has purchased some items. So what is the day of the week? What is the timestamp he purchased? Okay, so how many frequent purchases are there between a particular period by Ram? Means month of the day, then month of the day and the week of the day, and purchasing timestamp of the particular person. So means week, month, and the particular hour and particular timestamp or particular day. All these details is comes under one feature. Features, I mean not one feature, so different features of timestamps. Similarly, there will be other features. Okay, so like that, we need to generate whatever the features are available based on the given text. Then we'll build our model. So usually in machine learning, there will be so many models are there like classification, clustering, so all those things. But particularly in NLP, we will use the classification kind of things using neural networks. So that is the main thing here. Then model evaluation we'll do. So once if you apply the model building, we need to evaluate how accurately our model is predicting the things. So whether they are meeting our norms or not. So we need to adjust the parameters based on that. Then once your model is good, it is predicting properly, then we need to deploy the model in the system. So in the particular application of the industry. So language models, basically, these are the computational models. So that have capability to understand and generate the new information from the existing text words. Okay, so previously these people depend on n-gram models, which is nothing but n-gram models, nothing but they will convert the text words into vectors and they will do some computational process here. Okay, so all these are basically depends on probability concept, where we use conditional probability. Probability, if you want to find out the next word given a particular word, so it completely depends on the probability concept, like conditional probability. And similarly, when we have the more number of variables given, so how you will predict a particular next word of a particular word. So that is the task here. Suppose you are typing something in ChatGPT. Completely it works based on probability concept and matrix multiplication. That's all. There is no much mathematics in that. Okay, just let me give 1 second. So then let's see what are the limitations of these models. Okay. So issue of rare or unseen words. Suppose there will be some unique words will be there. Suppose if you type some word which you cannot find out from ChatGPT or any other model like Perplexity or means some rare words I have given. So for example, in our project, we are using a new computational framework. If nobody knows about that framework, suppose if I give the name of the new framework in the ChatGPT, it won't understand. So that means it don't know ChatGPT or Perplexity how they will work means initially we need to provide some training data for that. Based on the training data, it will understand. Then based on the probability of those words, existing words, it will predict the immediate next word. So if that machine don't know about unseen words, so it cannot say anything. That is the issue of rare and unseen words. Problem of war fitting. So I mean, more information is available, and it won't. I mean, it won't predict the proper value. Means so there is a thousands of words given word. So then we cannot get which one is the next word like that. So the difficulty in capturing complex linguistic phenomena. For example, if you take the biological networks, bioinformatics networks. So if you give some text words, it's difficult to understand what is the relation between two nodes. So when you talk in terms of motifs, so there will be called as concept known as motif. Motif are nothing but the relationships between the nodes in biological networks, bioinformatic networks. Maybe it is called as genes also. Okay, so people are working now. The research people are continuously working to resolve these kind of issues. So then in natural language processing, these are the fundamental tasks. Okay. So first one is the information retrieval. This information retrieval, already we have developed so much of things. This is the basic thing we can say. That is nothing but Google, what we call it as Google Chrome, if you see. So it is a search engine, sorry, search engine. So Google search engine is nothing but works based on completely information retrieval. How you will retrieve the data based on the Google page rank. What is the page rank? Page rank is nothing but it's nothing but finding the eigenvalues and eigenvectors. It will find out the maximum value of the eigenvector, then it will retrieve the corresponding words in the search engine. That is nothing but the Google page rank. Okay, so then sequence tagging, then we will give a sequence of words. Then we need to predict what are the information relevant to that sequence of words. That is nothing but sequence tagging. Then sequence classification. Okay, it's a kind of classification which we required based on some applications. You see here sentiment analysis, then topic modeling, spam detection. These are nothing but sequence classification. Means if you are getting some mails, whether they are spam or not. So such kind of classification comes under the sequence classification. Speech processing. Now everybody is using, even a villager is using. So if you say Google, if you ask in something in terms of voice, it will give the text word for us. So text to speech, speech to text. This is nothing but speech processing. Then text comprehension. This is another application I will show you. Then text generation. So you are doing something. So I am a PhD guy. I have this thing. I want to do something. Then ChatGPT will give some other new information. This is nothing but text generation. So if you want to see specific applications here, we can see like this. So for speech processing, speech to text, text to speech are applications. Then for text comprehension, dialogue understanding, reading comprehension. So if you give some dialogue, then it need to understand. Means some text, if you give, it need to understand thoroughly. Text generation, summarization, machine translation, question answering. So if you see in Perplexity, if you throw a research paper, it will summarize and it will give the entire meaning of that paper. That is nothing but summarization. Machine translation means translating one thing to another thing. Okay, one language to another language. Then question answering. So if I want to prepare some data science, or if I want to prepare GATE exams, let us say give me some question and answers relevant to the GATE examination in linear algebra. So it will throw all those questions. Okay, so this is nothing but all question and comes under the question and answering. Okay, so then so information retrieval. So this is called as document ranking and keyword extraction. So if you type something in Google, so relevant to that keyword, it will give all the important text words. So based on the Google page rank, which is nothing but eigenvalues and eigenvectors. Okay, so then sequence tagging is nothing but name and entity recognition. Suppose if you throw a particular document, it will give all the subject words, all the object words, and what is the relation between subject and object in terms of verbs. It will give this information here. So this will be helpful in building knowledge graphs also. So parts of speech tagging, so word sense disambiguation. Okay, so means whenever there is some ambiguity between different words, then it will tag all those sequence words. It will tag. Okay, so basically LLMs, NLP will come subset of machine learning. Then again, it's a LLM is a subset of NLP. So where we have the massive data sets. So we will train that data sets with the model, and we will try to get the new information from that model. So this is the main goal in LLMs. We have the already predefined training data will be there. We will feed the training data to the machine. It will generate the new information. It will predict the new information. Those are nothing but LLMs. Okay, so all these LLMs works based on neural networks. So multi-layer perceptrons means when you have the words and throw the words in multi-layer perceptron, so means with many number of hidden layers, it will give some predicted values. It will generate some predicted values. So this is nothing but LLM, large language models. Okay, so basically now people are using transformers. The main concept of so so rather than while using these neural networks, people are using transformers, which is nothing but encoder and decoder technique people are using now. So models like GPT, Llama, so Cloud series, and many other things, Gemini. Okay, so many hundreds of tools are there. All these are working based on the LLMs only. So if you see in evolution of large language models, I mean, this I have given only, but it's difficult to explore all these things within short time. So if you see the statistical learning models, N-gram models, Markov, the Markov models, back-off techniques and smoothing techniques. Markov models, we are very much familiar mathematicians based on the conditional probability. So given a particular node, so we will find out the probability of another node. So there will be some chain of nodes will be there. Chain of Markov models are also there. Okay, so these are helpful um, to predict the probability of the particular node given given some sequence of nodes. So these are developed in I think 1900s or 1990s might be. Okay, so these are statistical learning models. Then neural language models recently in 2000 from 2010 to 2015, people have developed word to vector. Means how you will transform your word to vector. So then multi-layer perceptrons, we have the neural network for classification. Then recurrent neural networks, another form of neural networks. Then GLOW is a kind of word to vector. This global vector representation. GLOW is nothing but given a text word, represent the that vector in the form of numeric elements in a global way. So this is called as global vector representation. This is also kind of word to vector. LSTMs, long short-term memory systems. These are also one kind of recurrent neural networks in NLP, where we'll apply in so this kind of all these transformer models. Okay. So pre-trained language models. So we have the another models, Elmo, then BERT model. So these are from 2018 to 19, GPT-1, GPT-2. Okay, so generative pre-trained transformer. GPT means generative pre-trained transformer, and slightly they are modifying. So they are improving up to now we have GPT-5 something like. So robot. So this is the modification to BERT model. So we have the BERT model. This model bidirectional encoding transformer. So this is nothing but there is a modification for this, which is nothing but Roberta model. Okay, then large language models we have 2022, 2022, GPT-3. So large language model means we will give pre-trained data, so in huge amounts of gigabytes. So that will take all the databases in the entire world, and then it will predict the new word. So whatever you give, so it will take all the corpus database and it will predict the new words in the transformers. That is the main thing. So these are some of the large language models. There are other models also. Only I have given these few. Now, if you see up to 2025, there are lots of new transformer models are there. Okay, so again there will be some modification known as Instruct GPT and BERT. So there people are using reinforcement learning. So for the transformers, which is nothing but RLHF. So then finally means when you apply the encoder decoder techniques, then applying the reinforcement learning. So that is known as ChatGPT. So then again there will be modifications for that, which is known as ChatGPT-4. Then multimodal capabilities and handling all the images, all the videos and text words. So previously we have only text kind of things here. In BERT, it will handle all the text kind of things. Now, when we have the multimodal capabilities, GPT-4, GPT-4 Turbo, DALL-E, so they will handle any kind of images. For example, if you give some video and if you replace my name, my face there, so it will do. Now we have the recent one more model, DeepSeek is also there. So lots of things are going on. So basically, these kind of, when you are doing word to vector, the fundamental concept is similarity of the words. Okay, so there are three kinds of similarities. One is the content based similarity, and the second one is the so we have, everybody, Pearson correlation coefficient, cosine similarity, and structural similarity measures. So these structural similarity measures, we have the Jacob similarity and SimRank. So structural similarity means when you represent the data in terms of a network, in terms of a graph, then how to find the similarity between two nodes. So in this way, structural similarity comes under the picture. There are hundreds of similarities in the literature, but only few we are mentioning here. But these are some of the different similarity measures. Content-based similarities. Content-based, only we have the numeric values. When your data is in terms of graphs, then structural similarity measures will come into the picture. Semantic similarity. So semantic similarity means you need to understand the text meaning of the given nodes, the given words. So the semantic meaning, so based on the text words, what is happening, what is the relationship between those two data points. So that kind of text meaning we need to find it. For example, Ram is a student of Hari. So student of is a semantic meaning. So these kind of relationships we need to extract. Such kind of similarities can be computed using TF-IDF factors, term frequency, inverse document frequency. So based on these two values, we need to apply cosine similarity here. So this similarity will be helpful, particularly in natural language processing. In graph theory, we will apply structural similarities. In normal similarities, we will apply Pearson correlation, cosine similarities when you have the numeric data points. So, yeah, sorry, this is a repeated one. Sorry, it went to back. Yeah, so semantic similarity. So now our NLP tasks, we need semantic similarity. So it measures how close in meaning to words, sentences, or documents. So in internet, in the database, if you have so many documents, for example, if you give linear algebra, lakhs of files will be there. Lakhs of files will be there in linear algebra. So if you want to check eigenvalues and eigenvectors, it will find out all the words which are relevant to eigenvalues and eigenvectors, and it will compute the similarities between those two text words, and it will give some meaningful word. That is nothing but semantic similarity. So similar meaning means high similarity score. Different meaning means low similarity score here. For example, if you give car and automobile, they have relevant words, it will give high similarity. If you give car and banana, there is no relation between car and banana, there will be a low similarity here. So in NLP, word or sentences are represented as vectors. Okay, so we'll use cosine similarity using dot product of the vectors, and then we know that the values lies between, always similarity between 2 points lies between -1 and 1. Okay, so word level similarity, you know how to calculate the things. For example, let us assume that a word, there will be word deep and there is another word learning, deep learning. So if let us say it's vector, I mean it has the values 1, 2, 2, 4, then apply the dot product, then similarity is 1. So that means between deep and deep learning, they are highly correlated. So they have high similarity. Okay. So similarly, if you take two sentences, I like deep learning sentence. I enjoy deep learning. How you will find the similarity between these two words means we will sum up all those vectors and then we will find the similarity. we'll apply the same way. We will apply the formula. Then we'll get the similarity here. So high semantic similarity here. So means you convert these words into vectors into 1 0 0 something like, then find the similarity. You will be able to find out the similarity between different sentences. So another way is, okay, yeah, some question, somebody's question, I think. Anybody is having a doubt?
Sir,
Yeah. Can I continue?
you can
Or any
continue, sir.
question? Okay.
Sir, students are in mute mode, sir.
Okay, fine, no issue. No
Thank
problem.
you, sir. Okay, sir.
Yeah. So another kind of metric measure to find the similarity of words in a particular set of documents. Let us say there are 100 documents. So I have two words, and how to find out the similarity. So how to find the importance of those two words means term frequency. Means how many times this a particular term or a particular word repeated in different documents. Okay, so term frequency measures how frequently a term appears in a single document. This in a single document. For example, so Rama killed Ravana, and you are reading Rama in something like, how many times the word Rama repeated in a particular page. So that is nothing but TF, term frequency. So number of times the term T appears in the document D, the total number of terms, so in the document T. So it means Rama, how many times is repeated in a particular document, and what are the total number of terms or words in that particular document. This is nothing but TF, term frequency. Total number of words, let us say 4. I am searching for deep, and count of deep is 1. So 1 by 4 is the value here, score here, 0.25 here. Okay, D1 is only one document we have. So that is why it's I mean, only one document, we will take 1 here. Sorry, one time it is repeated, but the document is also 1 here. So then next important measure is inverse document frequency. So this is this metric measures how important a term across the entire corpus, entire database. Suppose I have a textbook. So what is the role of Rama in the entire textbook, not only in a single page, the entire textbook? How important Rama word in the entire textbook? So the formula is, so inverse document frequency of T, the term is log of n by df of T. Okay, what is n? N is total number of documents in the textbook. df of T is the number of documents containing Rama term T. That means df of T is nothing but in how many pages we have Rama. That is the df of T. Okay, so if you see, I like deep learning. D2 is deep learning is powerful, and I'm giving 3 documents. I like NLP. So, but I want to find out the importance of deep. So you need to calculate like this. N is 3, total number of pages 3, and you are it repeated twice, deep. So 2 by 3, log of 3 by 2. So in this way, it will give some score. Okay, IDF score it will give. So TF IDF. So how you will compute the, so whatever we have the TF IDF scores. So if you multiply those term frequency and inverse document frequency, if you compute, so you will get some score 0.25 into log 3 by 2. Okay. So then if you have high TF score, the term is important in the document. If you have high inverse document frequency, the term is rare across documents, means unique word in the document in the textbook. If you have high TF-DF, the term is both frequent and discriminative, means which is important. Okay, so this is the means it will say the importance of a word whenever you are searching in a database or in a text. So based on this one, we can calculate the similarities also. So some of the key insights are common words is they will give a low TF IDF score, and domain specific norms, for example, machine learning, deep learning, will give high TF-DF. But that means they are very important. Okay, so there is another concept known as okay, so word embeddings means converting text words into vectors into numeric values. These are called word embeddings. So here converting words text to words is not that directly. For example, ram is there, r for 1, a for 1, m for not that one. If your word is ram, what is the next predicted word in a particular sentence? So here we are predicting the next word. We are not directly transforming the words to ones and zeros. Okay, we are applying some probability. Ram and Hari are there in a particular college, let us say BEC. Ram is a good friend of Hari. And who is the other friend of Ram? If you want to predict that. So I will give some previous pre-trained data to the model, and it will say another friend of Ram is some Rajesh. So that means we are doing prediction. We are embedding based on probability of the next word. We will convert text to numeric values here. That is the difference here. We are not directly converting the text words into numeric values. Based on the probability scores, we will convert the text words to numeric words. That is numeric values. That is the example of word embeddings. There are two types of word embeddings, but only since we have less time, I will discuss only one method here. TF, IDF, I have already discussed. So frequency based methods, count vectors, and TF, IDF means. So here in this model, some kind of co-occurrence matrices we will find out here. So means like just a kind of correlations we'll make here in this model. Then prediction based methods, we have word to vector and global vector representation and fast text. This is another model. But unfortunately, so we have little time. So only one thing I will cover here. Okay. So word to vector representation so was developed by this Thomas Micolo in 2013. So these are simply called as embeddings. Embeddings means convert the text words into numeric values based on some probability scores or some predictions. Okay, so these representations used in downstream tasks like sentiment analysis or opinion polling. So there we will use this kind of embeddings. So the primary goal is not the prediction itself, but the extraction of learned weights from the neural network, which are then used as embeddings to represent the words. How it will find out the prediction scores means, first I will feed all my text words, Ram, Hari, Gopal to the neural network. So in neural networks, we have the bias and weights will be there. In linear regression, we used to predict the values. For example, if you say predicting the polynomial, method of least squares, fitting polynomial curves. So there we have the whatever we have y is equal to ax plus b. B is nothing but bias there. Okay, and yeah, there we have the bias and weights are there. Sorry, I'm confused. So which one? A and B. Whenever we have y is equal to ax plus b, one is the bias element and another one is the weights. A is the weight. When we call it in linear regression in method of least squares, when we call y is equal to ax plus b, A is nothing but weight where we will give it to the neurons in neural network, and B is the bias. We will adjust based on the activation functions. Okay, so those are beyond this topic. I mean this lecture. So there is a separate lecture. But usually whatever people are doing in neural networks in regression classification, mathematicians are already done in method of least squares. Okay. And fitting the polynomial curves. All those are people are now they represented, they are using neural networks and they're saying something is new. That is not new. Already we are doing in fitting the straight lines, fitting the polynomials. Okay. So here people are saying embeddings are not simply extracting the next word prediction, but those cores are learning from the weights of the neural network. And then we are predicting the words into numbers, the words into numeric numbers. It's a very long process is there. We have the text words. We are feeding into the neural networks. So based on the weights, whatever we are giving to the nodes in the neural network, based on the learning function, like let us say softmax function, ReLU function, and based on the bias values, that network will produce the output in terms of numeric values. Those are nothing but embeddings of those text words gave in the input. Okay, so the main objective is here to train the classifier to predict how often a word is likely to appear near another word. Means Ram is a good boy. So that means if you give that Ram is means it will check whether it will check nearer to all those points. Ram is a good boy. Ram is a professional scientist or whatever it may be. It will give all the nearby words when you feed his data into the neural network. That is the main purpose of these word to vector embeddings. So machines cannot understand words directly. So words must be represented numerically. Then one hot encoding is sparse and meaningless. So initially we will give Ram Hari Gopal. So it will convert 1001. That is known as one hot encoding technique. Means converting categorical variables into numerical variables. That is called as encoding technique in machine learning. So word to vector learns dense semantic vectors. Means whenever words are dense, then it will work properly. Means if your words are sparse, it shows poor performance. Means whenever you have when you convert the word to vector into a matrix, if the matrix is sparse, then it will show poor results. If your matrix is dense, it will give good results. That is the meaning here. So for example, let us say I like deep learning. Okay. So I like deep learning. So I is let us represent the index as I is 0, like is 1, deep is 2, and this is 3. Since we have 4 words, so we are representing as dimension is 4. See, this is this is a theoretical topic people are working now in natural language processing, but the base behind this is mathematics only. Simple kind of mathematics only. Okay. So we are not doing any differentiation, we are not doing any integration, but we will do matrix multiplication. Okay, so if you see the vector, if you one hot vector for I, since I am talking only in terms of I, so its value is 1, rest of the elements are 0. Similarly, like the second element, other elements are zeros. Third element, other values. Fourth element is 1 and other elements are zeros. This is known as one hot encoding technique. There are so many encoding techniques. So there is another model known as skip gram model. Nothing but so context word, my context, I like deep learning. So like is the context word. Target word is deep, already given. Target word is given. Deep is given. And we need to predict the next context word. What is the other meaning it will come? It will give in the next prediction. Skip gram predicts surrounding context words given a target word. Means I have given, I know the context word like, and I have given the target word deep. I need to find out what are the other surrounding context words. Okay, that is what happening So when you type something in ChatGPT, we are finding all the context words around what we are typing in the chat. Okay, so this is the in skip-gram model. This is the fundamental. These are the fundamental steps here. So target word is deep. So I know the deep. So that means in the deep, what is our representation? Deep is 0010. So it will take initially 0010 here, and we will multiply this vector with the W. So I mean, so all the x1, x2, x3, 4, we will multiply with the weight vector. So weights will be in the, so it's not physically we look here, but it will have in neural network. So based on the how we are feeding the values, so those weights will be the weight matrix. So embedding matrix is W is nothing but this dimension 4 into this D. Okay, so that means this we will take 4 into D. I will show you what is D. Okay, so then next in the hidden vector, so multiplying H into X into W. So we have the W weight matrix. We have the all the vectors. So X into W is nothing but H. This is hidden vector. So which we will get 0. Let us assume this value is 0.4 and 0.3. Then output will be another D into V matrix. So in neural networks, there will be so many layers. Suppose if you take 2 layers, so it will come like this. Then again, this output will be the input of another layer. Then again, we will apply H into W. Okay. So H into W dash. Sorry, this is W dash. Then we will apply some soft matrix. Then it will predict some context probabilities like and learning. Okay. So it will give deep learning or deep like it will give. 2 context words it has predicted finally when you apply this whole process in skip-gram model. So I will show you how it will works. Let us say I have this word embedding matrix. Okay. So I need to, so my priority is for SITs. So I am assigning these values vector 1, vector 2, vector 3, vector 6 and so on. So then it will do some computation here based on the weights of the neural network. It will give some values here. Those values will represent VC1, VC2, VC3. Then again, whatever we have shown, so the matrix multiplication, we'll do something like here. H is equal to XW. It will give another new values. It will provide like this. Then it will apply some softmax function, means what are the existing values and what we are going to predicted values for the next layer. Means initially it will take the input values and it will find out some matrix multiplication it will do. Then based on the weights of the neurons, it will output some values. Then again, it will go to the next neural network. The next weights it will take, it will do some computation. Then it will apply the soft matrix function here, and then it will produce some values. So we need to check whether it is predicting correctly or not, whether any loss is there for us. Based on the cross entropy loss, we will find out how much efficient this model is predicting the values accurately. So it will produce all the probability scores at the final output. All those are nothing but conditional probability. That means it is finding probability of on value given this SITS score. Okay, so it will internally compute this score and it will give some score here at this cell here. So you see here all the cells and it is showing thick red here. Okay, this is this information I collected from Google for better understanding. Just let me maximize this. Okay. So here, if you see here, SITS, this is the vector of SITS. Okay. And they are feeding it to the machine. Then finally what it will do? It will find out this center computational word here. I mean, context word embedding it will do. V in D it will do. And then they are applying some dot product here in terms of soft matrix. Softmax, what it will do, let me show you what is the responsibility of soft matrix. I kept because I will forget sometimes. Okay, softmax operation is crucial activation function in neural networks that converts a vector of raw scores into a probability distribution, making it ideal for multi-class classification tasks. Multi-class classification means we have so many vectors, v1, v2, v3, v4. So we need to classify all those vectors based on the probability score. So that is why it is called as multi-class classification. Okay, so this is crucial when you are converting raw scores, raw vectors into probability distribution. That is why this softmax works properly. Okay. Okay, so might be this will be difficult to understand, but slowly you will be able to understand. Okay, so then again, so you see here basically what they're doing, they're applying matrix multiplication only, V into D. Okay, so they are doing the kind of matrix multiplication here. Okay, so then applying soft matrix, matrix vector product. Okay, and then they're doing some logics here, finding some probability based on multiplication of transformation of U, T, and VC. From this, we will get again matrices. They are doing multiplication here, then applying soft max. Okay, so then they are getting some probability scores. So based on this scores, next word it will give. What is the next word of sits is on, I think. Okay, so then they are computing some, what is the, whether it is predicting properly or not, it will compute based on the weight score and some computational score here. Little bit confusion is there. Okay, so if you see here, predicts context words from a target word. Window size is 1, means it will predict only next one word. That is why it is saying as window size is 1. Suppose if you want to predict next two words, then window size will be 2. So number of words on each side of a target word. Okay, fine. So training pairs, how they will give the pairs? I like I. So like means all the combinations of the words they will give here as the input. So one hot vector size is 4. 4 words are there. Only two layers, two hidden layers they are taking here. Okay, then they are applying softmax function here over the vocabulary. So let us say, assume that input to hidden weight matrix is this one. This is the weight matrix. So we are confusing what is W, what is D. So this basically we will get the weight matrix here. When we have the neurons, in layer 1 there are three neurons. Layer 2 there are 4 neurons or 3 neurons. So these horizontal rows represents the weights of those layers. Okay, each row is a word embedding. This is the one row, one embedding, then another embedding, and so on. So this matrix is learned during training. So during training only we will able to compute these values based on the whatever the vectors it will take from one hot coding, then multiply one hot coding with the weights of the layers of the neural network, it will give the W matrix. Okay, then they are doing X into W. So X means here deep. What is deep? Deep vector is 0, 0, 1, 0. So they are multiplying with this one. Okay, XW they are doing. So 0 0.4, 0 0.3 we are getting for deep, for the word deep. Okay, so then H is the word to vector embedding of deep. Okay, so hidden to output matrix. Then again W dash is the next weight matrix. Okay, then score computation is H into means this is the weight. Another layer, if you go for the second layer, it will give the weight matrix like this. Then whatever you have the previous H, they are multiplying with the W dash here. Okay. So previous H is this one. They are multiplying here with this W dash. Okay. Then finally they are getting scores. Score of I is 0.11, score of like is 0.09 and so on. So if you see here 0.38 has high score. That means probability of the given target word is deep and the weight of the next value is applying after applying soft matrix e power sw and sum of all the words, sum of all the values here. So highest probability is assigned to learning. If you see here, learning has 0.38. So then they are applying soft max for this function. Okay. So skip gram maximizes so the value of logarithm of probability of those scores. Given a target word, so compute the probability of the next word. So this is the skip gram model. Encourages similar words to have similar vectors. Okay, so after training, so it is giving those values. I has 0.05, 0.01 and so on. Means after applying softmax. Deep and learning are close in embedding space. If you see here at the final output of the second layer, so deep has 0.45 highest score and learning has highest score. That means learning has high chances to exist in the next word for deep. So that is why this is showing, these are showing high similar values. Okay. Okay, so key takeaways are one hot vectors are sparse and meaningless. Word to vector lands dense embeddings via prediction. Similar contexts, similar vectors. Okay, found. Okay, these are useful for graph kind of graph kind of extractions. Let us say knowledge graphs. If you see those kind of semantic similarity or skip gram model will be helpful. Basically, if you see the graph neural networks, there it helps a lot applying this kind of skip gram model. Okay, the core concept behind LLMs, ChatGPT, GPT-3, Instruct GPT is the self-attention mechanism in the transformer. So the concept behind large language models is transformer. Transformer is a kind of encoder and decoder technique which works based on the neural networks, and it follows self-attention mechanism. So some kind of what kind of query will give, what is the value and what is the key. So that is nothing but self-attention mechanism. I will show you. Maybe people are feeling a bit difficult to understand, but slowly if you see, you will able to understand if you take one example. But that we need to train the model. So in Python using neural network, then only we will able to understand clearly. So how a transformer works here? So basically a transformer works given a context sequence. Let us say Ram, Hari, Gopal, or Ram is doing good, or Ram is going to college. Given a context sequence X, the language model aims at to predict the next token Y. That is the main goal. Okay, so I have given a word. So Ram is getting, more money in this month. What is his step in the next month? So what it will do based on his previous context words, it will predict the next word. So it is okay. So basically, it is nothing but probability. So it is X is nothing but sequence of words. Okay, and you need to predict the Y, small y. So X is nothing but, so a sequence of text words already happened. So Ram is earned this much of money in November. So let us say first week this money, second week this amount of money, third week this amount. How much money he is going to get in January? So that is what I want to predict. Okay, so given a sequence of context words, find the next word. That is the main objective what we are doing here in ChatGPT or Perplexity or whatever it may be. in all the AI models. Okay, x1, x2, xt minus are the tokens in the context sequence, and t denotes the current position. Okay, this is nothing but probable conditional probability. Okay, so we are applying chain rule of decomposition. So using chain rule of probability, the conditional probability of the entire sequence can be factorized like this. So simply we will take multiplication of all these values. Means if we have the y has some small y1, y2, y3, how much amount I will get in January 1st week, January 2nd week, January 3rd week, then it will do this kind of decomposition. So the model predicts one token at a time, and each prediction depends only on previously generated tokens. This is obviously. So this process continues until a complete text sequence is generated. So until you will get a text sequence, it will iteratively takes the data from previous values, previous tokens. So tokens means when you give a sentence, it will divide into words, which is nothing but tokenization in NLP. Okay, attention mechanism, how it will works. So basically we have the query queue. Let us say Ram is earning some amount of money, and how much he will earn in the month of January. That is query. There will be some key values here. So this is the Q means query, K means key, and value means what we need to find out. So there we are applying softmax function for this matrix product here. Q into K transpose by square root of D, K into V. Okay, so this is, query K, key and value, and we are applying some score here, matrix multiplication, and then we are applying softmax. Okay, softmax we need to apply. Why we need to apply soft? It is an activation function where we'll get where the weights will be adjusted in the neural network, and it will give proper scores. That is why we need to apply the softmax to avoid the losses, to avoid the uncorrected predictions. Means it will give accurate kind of predictions if you use this softmax function here. Okay, then finally it will give the relevant context vector here. Okay, because it will give Ram in the first week he will earn, let us say, some 1,000 rupees. So 1,000 rupees from a professional teaching, 1,000 rupees from online teaching, some kind of information it will give. That is why it is called as context vector here. So how this works, Q, what is Q, what is key, what is V, and what is DK means. All these are, the given text words. Okay. Each xi is a token representation, means embedding each xi we will convert into 0 and 1s. So it's nothing but embedding is nothing but positional encoding. Using one hot encoding, we will convert into 0 and 1s. Then Q is nothing but x into WQ. So x is all the vectors we have the capital X. Okay. K is x into WK. These are weight vectors. Then WV. So WQ, WK, WV are learned weight matrices. Means whatever you have the neural networks, when you feed these vectors into the neurons, we have the learning weights will be there. So those are nothing but in different layers you have the WQ, WK, and WV. So one is for query, one is the weights of the wherever you are feeding the query. Those weights will be Q, WQ. Another one is WK, relevant to these are the weights relevant to the key, and another one is relevance. WV is the weights relevant to value. Okay, this actually there are pictures which I cannot show here because those pictures I need to draw, so it's difficult for me to draw how WQ, WK, and WV can be projected. So that is the that pictorial representation will give much idea than mathematical here. So basically, a transformer is nothing but an encoder decoder model that uses the attention mechanism. So in attention mechanism, we will apply this kind of matrix multiplication. Okay. So this is a weight matrix relevant to query, weight matrix relevant to key values, weight matrix relevant to value. Okay. So that matrix representation is known as attention mechanism here. Okay, might be Jagannath Garu has explained in yesterday's video. I saw this one, attention mechanism. Okay, so then next, so there are two kinds of things. Some tools are using encoder decoder kind of techniques. Some are using only encoder techniques. Some are using only decoder techniques in their AI tools. So encoder will be like this. First, what it will do, encoder, so it will set multi-head self-attention. When you have the more multiple neural network layers, so there you will get multi-head self-attention you need to apply. Then from this core, again, we need to feed into the next neural network, so which is nothing but feed forward network. Finally, you will get n encoder layers here. Okay, so then we will decode that into masked multi-head self-attention. So there will be two things here while encoding the things. One is the MLM, which is nothing but masked language modeling, and the second one is next sequence NPS, next predicted sequence. So two things are there. One is the masked language modeling. So you will I mean the output whatever is coming from one neural network to another neural network, it will be masked. We cannot see that one. But next, when it is giving the output, it will be converted into NPS, next predicted sequence. So that next predicted sequence will give some output. Finally, from all the neural layers, whatever will give the outputs, those will be merged based on the masked multi-head self-attention. Okay, so that will be finally that output will be decoded here at the end of the encoded layers. Means encoder will take the input, we will apply multi-head self-attention on different layers. Then again we will forward it to the next layer. Okay, so then we have the encoded data based on the ML masked language modeling, and so this masked we will apply decoding on this masked multi-head self-attention. Then we have the encoded decoded attention. Finally, whatever you have masked, so it will give the text words. It will avoid that masked language. Then finally, it will give the next prediction sequence through n decoder layers. This is the procedure here. Okay. Might be it is difficult to understand here. If you read thoroughly, you will be able to understand. So used in machine translation, summarization, and sequence to sequence tasks. This kind of encoder and decoder technique, we will use these kind of applications here. Okay, if you see BERT model, so BERT is nothing but bidirectional transformer. This is a both ways. It will transform the data here. So here it will, divide the data into different tokens or segments and positional values where we will convert into zeros and ones. Then it will apply multi-head self-attention. Means self-attention means so you are applying the matrix multiplication based on the what is the your query, what are the keywords, what are the output values. So based on these kind of matrix multiplication, so it will apply multi-head self-attention. Then it will forward. So when you have some scores based on multi-head self-attention, it will feed those values to the next layer. Then so the transformer will encode those values. Finally, it will provide only contextual token representations. That means BERT is using only encoder values. It's not using any decoder values here. So this is only encoder model. BERT is a encoder model. Okay. So this is, I want to check. I forgot. Let me check one time. Just a minute. BERT long form. You will get an idea. It's bidirectional encoder representation form. So this is nothing but bidirectional encoder representation form. So BERT uses only encoder technique, whereas ChatGPT uses decoder only, I think. Okay. Yeah, you see here, no decoder, no casual masking. Trained using masked language modeling, MLM, used for NLU tasks, neural language understanding tasks like classification, question answering, named entity recognition. For classification of text words, question answering. Suppose if you give some questions, it will give the answer in ChatGPT. So this comes under this named entity recognition. So if you give some para, it will give what are the names, what are the city names, what are the human names, and then what is the object, what is the subject, what is the verb. Okay, it will give all the information. Next, GPT. If you see GPT architecture, generative pre-transformer, chat GPT like kind of things, decoder only transformer. So it will take the input embeddings, token, it will tokenize the things and it will make into position vectors. Then it will use masked multi-headed self-attention, then send it to the feed forward network. Then it will decode the things. Okay, it will decode the things. Okay. So then it is applying softmax functions and then it will predict the next token prediction. This is the different kind of rather than using encoding, it's using decoding. Okay. Decoder only transformer, ChatGPT, and then casual self-attention, trained using auto-regressive language modeling. Okay. So basically, if you see here, transformer and BERT and GPT, how they are. Transformer is the basic thing. BERT is also advanced level of basic transform, another transformer, and GPT is also another transformer. But the basic one is encoder decoder transformer, and this is only encoder only. It will use only encoding techniques. It will use decoding technique only. So that means in encoding method, so we will convert the text to words, text to numeric values. We will feed it into the numerical values. Then we will apply the masked. So whatever you have the masked language modeling that we will apply. Okay, then finally those values we will give it to the next layer. Then we will get the prediction of the next words. Okay, but in decoder, before applying the what we call before applying the embeddings, we are simply doing decoder here. We are applying masked self-attention, then casual masking, all those things we are doing here. I mean, little bit understanding is required here in GPT. Okay, attention type is self plus cross attention. And one more thing, whenever in all these transformer models, transformer, BERT, and GPT, the computational process will do parallelly, not sequentially. In neural networks, things will go sequentially. But here in transformers, things will compute parallelly. No need of wait for the all other words. Each word compute parallelly and it will give the output. Okay, so if you see here, here the masking is decoder casual mask, and there is no masking in BERT model. No masking it is showing in BERT model. Okay. In BERT model, there is no masking here. So that is the difference between decoder and encoder. So casual masking is there in GPT and sequence to sequence likelihood. We will predict the probability scores of sequence to sequence. MLM mask language we are using, auto-regressive language model we are using. Source to target and bidirectional. So here only source to target. Here bidirectional is there. If you give the target word and it will find out the relevant context word. Or if you give the context word, it will give the source word also. That is the BERT model will do. But in GPT, only left to right it will give. Means if you give the source word, it will give the target word. Okay, so these are some of the applications and some example models. So original transformer is T5 and BOT. For BOT, these are the very different variations. BOT and Robota, this is the latest one. And GPT, we have variations. Recently, we have the GPT Turbo and GPT-5 also. Okay, so yeah, that's all. I don't know how much you understand these things, but little bit efforts are required to understand these things behind this transformer kind of things.
Thank you, sir.
Yeah, so
Sir, thank you very much, sir, for your efforts.
yeah, so I mean, one more lecture is required to understand all these things properly.
Okay, sir. We will see in future, sir. Definitely, we will utilize
Yeah.
your services.
So any questions? Any industry kind
thank
of questions?
Thank you, Ramlingasrao Garu, for your lecture on foundations of large language models. Okay. This is the time for a question and answer session. So, as the participants are Hughes, any participant who is interested in clarifying his or her doubts, please come forward to post their queries in the question and answer box. Post their questions in the question and answer box. Sir will clarify the same.
I can't see the chart here. I'm unable to see the chart actually. Yes, now I can see, I think, yes.
Once again, participants are requested to post their queries in the Q&A box, if any. Sir, if any questions come from our students, we'll forward to you, sir.
Please,
Definitely.
please share, sir, please. So actually, this is kind of theoretical presentation, but mathematically, it's a bit difficult process because it's all related with neural networks. Neural networks. So
Okay,
another session is required to do the things practically using Python, if time allows.
Definitely, in the coming workshops, we'll utilize your services, sir. Definitely. Thank you.
Sir, if you come to Bapatla or Chirala, please inform to us, sir.
Okay, sir.
So if you interact directly, it will help a lot to the student community.
Yes. Next time we'll plan only hands-on. So
definitely, please
so that we'll
give
do.
the information if you come nearer to Bapatla.
Definitely, sir.
So
even if
definitely
5% students are there, we will be benefited, sir. That's all.
Definitely. See, actually, for our students, all these theory are not required. Only hands-on is required.
Okay.
And they need to learn all the data science tools, processing tools, visualization tools, everything. Whatever industry is asking for the skills from the students, those they need to try.
If you take 3 hours of time, definitely it will useful to the community.
We'll plan next time offline. We'll plan that will be
Definitely.
better than online.
Issue of going online, hands off means it is always better to go for offline.
Yeah, offline only. Definitely we'll plan. So let's see. I will tell you before only, then we'll plan.
Thank you, sir.
Sure.
Thank you.
Thank you very much, Sardigaru. Thank you, Professor Narasimha, for giving me this opportunity. I'm not sure how much people understand this.
No, wonderful. Today you delivered
complexity is there
no
to understand the things.
Sir, there are some students, sir, who are saying they are little bit following and they are also satisfied, sir. Not all. Some 5 to 10% are there. Some people are following, sir. No problem.
Okay.
But not all. I can say that.
Yes.
Please stay with us half an hour.
Okay.
So we are going to conduct the valedictory function, sir, today.
Sure.
It will be finished within half an hour.
Okay, fine.
So your valuable presence is appreciated.
Thank you, sir.
Thank you, sir.
Thank you one and all for your good response and valuable support. Expecting the same cooperation in the future workshops which we are going to conduct also. Okay. Today's session concludes with vote of thanks by Staff Coordinator Dr. M. Balaya garu.
Good evening to all. On behalf of the Department of Mathematics and the participants, I would like to express my heartfelt thanks to our today's resource person, Dr. T. Ramalingeshwar Rao sir, Senior Data Scientist, Advanced Quants Analytics, Aqua, BFSI, A&I, who gave such a good and informative presentation on foundations of large language models. Despite of his busy work schedule, he gladly accepted our invitation and gave a valuable talk in today's session. Thank you very much, sir. I would like to thank our beloved head of the department and convener of this international workshop, Dr. Keviran Acharyalu, sir, who guided, motivated, and supported us to do this program and encourage us to shape out today's program. I would like to thank our principal madam and our management, Bapatla Education Society, for providing us all the facilities and encouraging us to conduct this program. Without their support, it would not be possible to conduct such a program today. I would like to thank Dr. K. Manidip Garu, HOD, Department of AML, Sri N. Kiran Kumar Garu, MCA HOD, and Sri P. Kodeswar Rao Garu, Faculty of MCA Department, and Sri U. Venugopal Garu, who are sincerely extending their technical support to us in conducting this international workshop. Thank you, one and all.
Thank you, sir.
Sir, please unmute your audio.
Now it is the time to conduct a valedictory function. Okay. 1 minute. Wait for 1 minute, please. Okay. Okay. The Department of Mathematics appreciates and congratulates all the students who participated in good numbers in the MBII 2025 competitions on the occasion of celebrating the 138th birth anniversary of the great and world famous mathematician Sri Srinivasa Ramanujan. National Mathematics Day celebrations 2025. MBII 2025 team is happy to announce the winners of the competitions. Okay. Many students actively participated. The following students won the prizes. Competition 1. Actually, the name of the competition 1 is Tell an Answer to Mathematical Concepts. First prize, B. Jahnavi, ITA. Second prize, Miss DLS Bhavani, CSEA. Third prize, Mr. M. Thaujesh, AMLB. These are the winners of the first competition. Tell an answer to mathematical concepts. Coming to the second competition, which is an interesting competition, innovative brainstorming ideas on mathematical applications. First prize, Miss A. Lahari, CSEA. Second prize, Miss D. Yogasri, Cyber Security Branch. Okay. Hearty congratulations to all the winners. Okay. Now I request one of our staff organizers, Srimati Fatima Madam, to present the brief biodata of Sri Srinivasa Ramanujan. Madam, please.
Good evening all. Sri Srinivasa Ramanujan was born on December 22nd, 1887 in Erode, a town in Tamil Nadu, India. His early life was marked by a passion for mathematics and an extraordinary ability to grasp mathematical concepts on his own. His formal education was at the town higher secondary school in Kumbakonam, where his interest in mathematics began to flourish. Despite of showing exceptional talent in mathematics, Ramanujan faced financial difficulties that affects his education. He attended Government Arts College in Kumbakonam but often neglected his other subjects in favor of mathematics. During this period, Ramanujan continued to independently study advanced mathematical concepts and worked on his own theorems and ideas. His lack of formal training did not deter him from making significant contribution to the field. Ramanujan's breakthrough came when he began corresponding with the British mathematician G.H. Hardy in 1913. Hardy recognized the brilliance of Ramanujan's work and invited him to England. In 1914, Ramanujan traveled to Cambridge, where he collaborated with Hardy and others. During his time in England, Ramanujan made significant contribution to number theory, infinite series, continued fractions, and other areas of mathematics. Even he faced challenges such as cultural difference, health issues, and financial constraints. Ramanujan's work continued to gain good recognition. In 1919, Ramanujan returned to India due to declining health. He was diagnosed with tuberculosis and other health issues. Srinivasa Ramanujan was passed away on April 26, 1920 in Kumbakonam, India at the age of 32. His legacy lives on through the numerous theorems, formulas, and concepts he left behind. Theorems such as Ramanujan's Hardy number and Ramanujan's prime highlights his profound contribution. Srinivasa Ramanujan was an extraordinary mathematician who made significant contribution to mathematical analysis, number theory, infinite series, and continued fractions, etc. His notebooks contain a wealth of mathematical discoveries, continue to be studied by mathematicians, and his contributions have left an enduring impact on the field of mathematics. Srinivasa Ramanujan received several honors and awards in recognition of his valuable contribution to mathematics. Srinivasa Ramanujan was elected as a Fellow of the Royal Society in 1918, becoming the first Indian to receive this prestigious honor. His fellowship with the Royal Society is a significant recognition of his contribution to the field of mathematics. Hence, the Government of India declared December 22nd as National Mathematics Day in 2012, making the 125th birth anniversary of Sri Srinivasa Ramanujan Garu. The declaration aims to promote the importance of mathematics and its applications in various fields. It also serves as a tribute to Ramanujan's extraordinary work and his impact on the world of mathematics. Thank you.
Thank you, Fatima Madam, for sharing the biodata of Sri Srinivasa Ramanujan Garu. Now I request our beloved head of the department, Dr. Kevalan Acharli Garu, to address the participants on this occasion. Sir, please.
Good evening to all. I extend a warm and heartfelt welcome to today's revered resource person, Dr. D. Ramalingeshwar Rao Garu, dear esteemed faculty members, and my beloved students. Before starting my convener's speech, it is my bounden duty to express my special thanks to today's revered resource person, one of my best friends, benchmate in my PG college studies, Dr. T. Ramalingeshwar Rao Garu. I have had a good association with him for more than 3 decades. He completed his PhD at IIT Kharagpur with commendable research on in large-scale graph analytics. I am grateful to him for his kind consent to deliver his valuable lecture despite of his hectic and busy schedule. I am deeply impressed by his simplicity, sincerity, commitment, and dedication to his work. By nature, he is a down-to-earth person. Thank you, Dr. T. Ramalingeshwar Rao Garu, for your valuable lecture. We gather here today through online to participate in the valedictory function of our international workshop. It is with a great pleasure and a sense of accomplishment that I came here before you to deliver my convener's message on this auspicious occasion. On the occasion of 138th birth anniversary celebrations of Sri Srinivasa Ramanujan, we have conducted a 1-week international workshop on mathematics, bridging ideas on innovations. This workshop is enriched with the enlightening lectures given by our revered resource persons. I am very happy to inform you that huge number of participants registered and most of them stayed with us till the completion of all sessions in every day. I appreciate all the participants for their interest to attend this workshop and make it as a good platform for professional growth and continuous improvement. When we put a proposal for conducting this international online workshop to our beloved principal madam, that minute onwards, our principal madam has been giving his valuable support, marvelous encouragement, and timely cooperation to us for conducting this workshop in an effective manner. In particular, we are all thankful to our magnanimous management for their continuous support and encouragement for conducting useful programs for students in view of enhancing their knowledge with the computational skills in mathematics. You all know that these type of programs can be succeeded only with the teamwork, seamless coordination, meticulous planning, collective efforts. Mainly our co-convener, Dr. P. Vijayasarthi Garu, made this international workshop a successful one with his good efforts, along with the supportive cooperation of our staff coordinators, I. Potraju Garu, Dr. M. Balayi Garu, staff organizers, Fatima Madam and Anita Madam, and also other faculty members in our department. I would like to express my sincere gratitude to Sri M. Lilin Babu Garu, Vice President of Institutions Innovative Council and a faculty member of ECE department. Actually, I was truly impressed by his simplicity, humility, dedication to assigned responsibilities, strong team spirit, and commitment towards academic and institutional development. So thank you very much, sir. I am also thankful to Sri P. Koteswar Rao Garu, faculty member of Department of MCA, for extending his valuable and timely technical support. His continuous presence and the support throughout the workshop greatly contributed to the smooth and successful conduct of this program. Thank you very much, sir. Further, we sincerely thank Sri V. Kiran Kumar Garu, Head of the Department of MCA, for his kind cooperation and encouragement, which played a significant role in the success of this workshop. The aim of this program is fulfilled and became a fruitful one only because of our esteemed participants. I express my sincere appreciation to each and every participant for their active participation and valuable cooperation for all the sessions to make this program a grand success. Expecting the same response from participants in our future endeavors also. Thank you one and all.
Thank you very much, sir. Thank you very much, sir, for your motivating speech and emphasizing the importance of the workshop. Due to some urgent academic work, our respected principal, Dr. N. Ramadevi Madam, is unable to attend today's session. But Madam conveys her message. Okay. Dear students, it gives me immense pleasure to address you all on this auspicious occasion of the valedictory function of the International Workshop, Mathematics Bridging Ideas and Innovations, MBII 2025. Over the past 6 days, this workshop has truly demonstrated how mathematics serves as a universal language, connecting ideas across disciplines and transforming innovative thoughts into practical solutions. Your participation, curiosity, and enthusiasm have been the real strength of this program. In today's rapidly evolving world, mathematics is no longer confined to classrooms or textbooks. It plays a pivotal role in engineering, data science, artificial intelligence, research, industry, and societal development. Workshops like MBII 2025 help bridge the gap between theoretical concepts and real-world applications, preparing you to face future challenges with confidence. I strongly encourage you to carry forward the knowledge, inspiration, and innovative mindset gained from this workshop into your academic journey and the professional life. Let this experience motivate you to think critically, explore creatively, and apply mathematics meaningfully. I appreciate the dedicated efforts of the Department of Mathematics, in particular, convener and HOD of Maths Department, co-convener, staff coordinators and staff organizers, resource persons, and all the students who contributed to the grand success of this international workshop. With these words, I congratulate each one of you for being a part of MBII 2025 and wish you great success in all your future endeavors. Thank you, one and all. All the best. Thank you, madam, for your wonderful message. Now I request our IIC Vice President, Sri M. Lenin Babu Garu, to address the participants on this occasion. Sir, Lenin Babu Garu, please.
Sir, good evening, sir.
You please switch on the video also, sir, if possible.
Yes, sir. Sir, is my voice audible?
Sir,
Yes, sir,
please.
your voice is audible, sir.
Yeah,
Yes.
sir.
Video is little bit not clear. Can you do it?
Good evening, everyone. Is it okay, sir?
Namaste, sir.
Is it okay, sir?
Yes, sir.
Video, sir.
Video. That's the.
Sir, I think you have some signal problem, sir. Please carry on, sir. Voice is very clear.
Voice is clear.
Yes. Okay. Okay. Thank you. Sir, good evening, everyone. Once again, and I would like to extend my thanks and appreciation for the Department of Mathematics for wonderfully conducting this MBII 2025. And we also, from IIC, we also thank Team Mathematics Department for making us a part in this MBII 2025. And as part of this, Dr. Ramalingeswara Garu, I have listened to your session, sir, on LLMs. And thank you very much for this wonderful session. And the organizers have taken care that all the relevant topics have been covered. And for the students who are listening to this, in addition to these LLMs, if you want to work in our EC department under the leadership of Dr. B. Chandramohan, we are working on vision language models also, along with these large language models. So for those who are interested in extending this session into practical work, we will help you out. So this is one opportunity students can utilize. And I have seen Ramalingeswara sir's presentation, and this is full of mathematical rigor. But as in practically, generally we, though we do not go to that level of rigor, we could able to implement, train the models, and test the models also. We are just riding the bicycle, but when you go into the mathematical rigor like Dr. Ramalingeswara and our mathematics department, it is like designing a cycle. Both are not same. So that's why we are proud of our mathematics department at BEC, because they are organizing consistently quality sessions, and they are bringing in quality resource persons also through all around the world. So this is a very good thing, and we again I am reiterating that with wholeheartedly that mathematics department in our BEC is doing a wonderful job, and we are proud of them. Under the leadership of Dr. KVLN Acharil Garu and the co-convener Vijay Sarthi Garu, Dr. Vijay Sarthi Garu, Balaya Garu, Anita Madam, Fatima Madam, and Pothraj sir. They have conducted this in a very wonderful way. So I conclude this by extending on behalf of Team IIC and all the students who are listening to this. I would like to suggest one book also, since it is relevant on Sri Ramanujan's birthday. You might have heard about the Man Who Knew Infinity. So you can go through that book, or in the same name there is a movie. So you can go through that movie also, and you can take one or two lessons and then apply it in your lives also. So apart from the mathematics, there are some life lessons in his life also, how passionate he is and how adamant he is when pertaining to particularly his food habits, and which led to his untimely death, etc. You can learn a few things on that aspect also. And I can once again I thank Dr. Acharil Garu for making IIC a part in this wonderful sessions, and I congratulate Dr. Vijay Sarthi Garu and his team for benefiting the students of a college. Thank you very much, sir.
So we are also thankful to you, sir.
Thank you.
Because you are extending your valuable and timely support, sir. Please continue in the same manner, sir, in future also.
Sure, sir. Sure.
Thank you, sir.
Thank you very much, sir, for your motivating speech. Thank you, sir. Okay. Now it is the time for listening about the response from the participants. So, students, one by one, you can say your response. I am reading the name in the order you can respond. Serial number 1, B. Jahnavi, ITA, Y25, AIT 415. B. Jahnavi. You can unmute and speak.
Good evening, respected teachers. I am Jahnavi from Information Technology. I am happy to share my experience about the 1 week online international workshop conducted by Department of Mathematics titled Bridging Ideas and Innovations. This workshop was very informative and useful. I learned many new problem solving techniques and smart tips, especially how to apply given conditions correctly. The sessions were well organized and easy to understand. I strongly believe that the knowledge gained from this workshop will be very helpful for competitive exams like GATE and other government sector examinations. I sincerely thank the Department of Mathematics and the resource persons for organizing such a valuable program. Thank you.
Thank you, Jahnavi. Next, serial number 2, DLS Bhavani, CSEA, Y25, ACS 453. DLS Bhavani, please. You can unmute your mic and speak.
Respected chief guests, designators, teachers, and my dear friends, good evening to one and all. I am Bhavani from CSEA. Today, I feel honored to speak a few words about the international workshop. An international workshop is a platform where people from different countries come together to share knowledge, ideas, and experiences on a specific subject. One of the greatest advantages of an international workshop is global interaction. It allows students and professionals to communicate with the international experts and build strong networks. The exposure helps us develop confidence, communication skills, and a global perspective. In today's fast-changing world, participating in international workshops is essential for personal growth. They prepare us to face global challenges and motivate us to achieve challenges. And I would like to thank the organizers for arranging such a valuable workshop and giving us this wonderful opportunity to learn and grow. Thank you for all your attention. Have a great day. Thank you, sir.
Thank you, Bhavani. Thank you. Next, serial number 3, M. Tojesh, AMLB. M. Tojesh, AMLB. You can unmute your mic and speak.
Good evening, sir. Respected HOD.
So, if possible, please open our video also.
It's not opening, sir.
No problem. Please, if possible, only please carry on. Please.
Good evening to everyone. Myself, Tojesh. I am from ML department. Today, I feel very proud to speak few words on the international workshop, 1 week international workshop conducted by our maths department of Bapatla Engineering College. This workshop helps us to understand that mathematics is just about numbers, formulas, but this subject plays an important role in our daily life. During the workshop, we learned about applications of mathematics in different fields. We learned about how the mathematics will help in the technology and AI-based platforms. How to they helped us. Next, we understood the role of mathematics in computer science and technology. Concepts like algorithms, coding, data analysis, and artificial intelligence are based on mathematical logic. Even mobile apps and games work because of mathematics. Another interesting part of the workshop was learning how mathematics is used in AI-based programs. Maths plays a major role in sports also. In conclusion, this 1 week workshop made us realize that mathematics is everywhere. It is in games. It is in games. It is not a subject to study. It's a powerful tool that shapes our world. I sincerely thank our college teachers and the staff of the Department of Mathematics for conducting this workshop. Thank you for giving me this opportunity.
Thank you, Tojesh. Next, A. Lahari, CSEA. A. Lahari, CSEA.
Respected dignitaries, esteemed resource person, faculty members, and my dear friends, good evening to one and all. So, my name is Lahari. Currently, I am pursuing my BTech first year in the Department of CSE. I feel truly honored to speak a few words during this valedictory function of the International Workshop. This workshop has been a highly enriching and informative experience for all of us. Throughout the sessions, we gained valuable insights that help us connect theoretically knowledge with the real world application. The resource person explained the concept in a very clear and engaging manner, making the sessions interactive and thought provoking. I sincerely thank the organizers and coordinators for their dedicated efforts in planning and executing this workshop so smoothly. Special thanks to our faculty members for motivating us and giving this wonderful opportunity to learn beyond the classroom. This workshop has not only enhanced our knowledge but also inspired us to think innovatively and globally. We will surely apply what we have learned in our academic and professional journeys. Once again, thank you to everyone who contributed to the success of this international workshop. Thank you and have a wonderful evening, sir.
Thank you.
Thank you, Lahari. Thank you. Next, D. Yogasri, serial number 5, cyber security. D. Yogasri, cyber security.
A very good evening, sir. I am D. Yogasri from Cybersecurity first year. I am deeply grateful for the opportunity to participate in this prestigious international workshop. It's not that easy to be a part of an international workshop in just first year of our BTech, and we really appreciate your presence and your support in this for our students, sir. Each session was exceptionally insightful, enriching my understanding of advanced mathematical concepts and their practical applications in engineering. I extend my heartfelt thanks to the organizers and resource persons for the dedication and valuable contributions which made this experience truly transformative. I really thank everyone, sir, for your support. We'll definitely try our best to apply this in our real life. And thank you, sir. Have a great day ahead.
Thank you, Yogasri. Next one, serial number 6, B. Harika, ECEA. B. Harika, ECEA.
Respected HOD Sir of Mathematics Department, honorable faculty members, resource persons, and my dear friends, a very good evening to one and all. I am Harika, studying first year BTech ECE Department from Bapatla Engineering College, Bapatla. I feel privileged to have this opportunity to speak during the valedictory function of workshop organized by our Mathematics Department. First of all, I would like to sincerely thank our Math Department for taking this wonderful initiative. I would like to share my experience. These sessions helped us to understand how mathematics plays a crucial role in engineering and higher education. The knowledge and skills we gain here will definitely help us in our future academic journey and in competitive exams and the technical subjects related to engineering. I would like to thank the resources persons for sharing the valuable knowledge and motivating us to develop an attitude towards the mathematics. In conclusion, I can confidently say that this workshop was extremely useful, inspiring, and beneficial for all of us. We look forward to many more such programs for our mathematics department in future. Thank you, on and all. Thank you for giving this opportunity. Thank you, sir.
Thank you.
Thank you, Harika. Next one, serial number 8, N. Salman Raja, ITB. N. Salman Raja, ITB.
Sir, good evening, respected teachers. My name is N. Salman Raj from first year ITB section. I have attended all the sections of our workshop. The lectures given by the resources persons are very helpful to us in understanding the applications of mathematics to variation field of engineering. This program is very useful for GATE and other communications exam, other competitive exam. Thank you very much for conducting such an useful event for us. I am very honorable to hear. Thank you, sir.
Thank you, Salman Rajan. The next one, serial number 11, K. Sidwila, ITA. K. Sidwila, ITA. K. Sidvila, ITA. Next one, serial number 12. P. Renuka.
Good evening, sir.
Renuka, na? Sidvila, Renuka, who is speaking?
Sidvila, sir.
Okay, speak.
Good evening, sir. Good evening to all of you, respected maths faculty and members of the Department of Mathematics and esteemed resource persons. The Department of Mathematics successfully organized a one-week online international workshop titled Bridging Ideas and Innovations in Mathematics. Through this workshop, I gained valuable knowledge of the new techniques and methods for applying various conditions while solving mathematical problems. This workshop will be highly beneficial for GATE examination as well as other government sector competitive examinations. Thank you for conducting these kind of innovative programs, and we are like to perform in every workshop. Thank you, sir.
Thank you, Sidvila. Next,
Thank you, sir. Thank
serial
you, sir.
number 12, P. Renuka, CSEC. P. Renuka, CSEC. Okay, next. Serial number 13, RKS Sai Sitaram, AMLB. RKS Sai Sitaram, AMLB, serial number 13. Serial number 13. Please unmute yourself and speak.
Hello everyone, my name is Sai Sitaram. I am from AML department. I am feeling proud to say to give the feedback session in this international workshop, because it is not a simple thing to participate in this international workshop in the first year of the BTech, and I can proudly say that the knowledge which we gain in this workshop, we can use this. It is useful in 4 years of BTech and also for higher studies. And also, I thanks to the Department of Mathematics, who being a source of motivation and knowledge and the confidence. And also, I thanks to the all departments who supports the Department of Mathematics and bringing this kind of workshops to us, international workshops to us. And also, I also sincerely paying my greetings to the Department of Mathematics HOD sir, Acharya sir, and Balay sir, and Ramalingastra sir, Vijay sir, sir, and all the members. And I also request the all departments to not only mathematics, also all departments to bring such a kind of workshops to every year for us, and gives more knowledge which is also useful and which we can grasp easily and enjoy happy in student life. Thank you for giving this opportunity.
Thank you, Sitaram. Next, serial number 14, Junaid Sheikh, CSED. Serial number 14, Junaid Sheikh, CSED. Please unmute yourself and speak. Serial number 14, Junaid Sheikh, CSED. Next one, serial number 15, U. Rupika, DSB. U. Rupika, DSB.
Good evening, respected faculty members, resource persons, and my dear friends. I am Rupika, building the registration number 522 in the stream of data science. I am grateful for the opportunity to share my feedback on one week international workshop on mathematics, bridging ideas and innovations 2025, which is scheduled from 15 December 2025 to 20 December 2025. First of all, I sincerely thank the organizers for arranging such informative and well-structured sessions. The workshop was very engaging and provided us with practical knowledge that goes beyond our regular classroom learning. The resource persons explained the concept in a clear and simple manner, making even complex topics easy to understand. I especially appreciate the real life examples and interactive activities which helped us connect theory with practice. These activities encourage us to think critically, ask questions, actively participate rather than just listening. This workshop has helped me gain new skills and improved my understanding of subject. It also motivated me to explore more opportunities for self-learning, skill development, which are essential for our future careers. These sessions are also boosted my confidence and inspired me to apply what I learned in real world situations. Overall, the workshop was very useful, informative, motivating. I believe it had added great value to our academic and personal growth. Once again, I thank the organizers, the resource persons, and everyone involved in making workshop a grand success. Thank you very much, sir, for giving me this wonderful opportunity.
Thank you, Rupika. Serial number 16, S. Kirti, ITC. Serial number 16, S. Kirti, ITC. Please unmute your mic and speak.
Good evening to dignitaries and faculty and student friends. I am Eskiti studying first year BTech in the stream of Information Technology in our esteemed college. First of all, I would like to express my sincere thanks to Department of Mathematics to give this opportunity to participate in the workshop. In this international workshop on mathematics, bridging ideas and innovations, I have learned many things through this international workshop like problem solving skills, logical thinking related to mathematics. One of the greatest benefit which I have got from this workshop is it strengthened my basics. The resource person share their knowledge to the participants and make me to learn more mathematics skills which I don't know earlier. Particularly, the workshop motivates me to apply mathematical concepts in our daily lives. This workshop helped me a lot to gain knowledge, confidence, interest in mathematics. I truly thankful esteemed resource persons, faculty of mathematics for giving me this wonderful opportunity.
Thank you, Kirti. Next, I am repeating serial number 14, Junaid Sheikh. Can you speak? Serial number 14, Junaid Sheikh. Can you speak now? Okay. Next one, serial number 17, Sheikh Rashmit Mumtaz, CSED. Sheikh Rashmit Mumtaz, Okay, speak.
Greetings to the respected HOD sir, professors, and everyone present in today's session. Myself, Rashmit Mumtaz Sheikh from CSE Section D, and I would like to provide my insight on the one-week online international workshop, Mathematics Bringing Ideas and Innovation, MBII 2025, conducted in respect of 138th birth anniversary of Sir Srinivasa Ramanujan. This informative workshop was organized by the Department of Mathematics. The first section by Dr. Kampa Lavanya on topic A Mathematical Key for Understanding Quantum Computing in the AI Era helped us understand the importance of mathematics in modern AI technologies. The session on topic Mathematics of Transformers by Dr. L. Jagannathan sir has helped us understand the mathematical basis of transformer models used in modern AI applications. The third lecture provided by Dr. M.A.S. Srinivas sir on the topic Role of Mathematics in Technology highlighted mathematics as the foundation of all technological advancements. The fourth session, led by Sir N.V.R.D. Kumar on topic Mathematics Behind Data Science, has helped us understand how mathematical concepts power data analysis and modern innovations. The fifth session on Differential Equations for Engineers by Dr. P. Nagarani ma'am enlightened us with the immense usage and importance of differential equations in solving real-world engineering problems. The final session was led by Dr. T. Ramalingeswara Rao sir on topic Foundations of Large Language Models, provided us an understanding of how large language models function mathematically. The workshop in total has been very effective in successfully connecting mathematical concepts with emerging technologies, enhancing both technical knowledge and analytical thinking. We would hereby like to thank the Department of Mathematics and all the resource persons for providing us with such a great opportunity. Thank you.
Thank you, Mumtaz, for your good collection of all the days and speech. Okay. Next one, serial number 18, D. Gayatri, AMLA. D. Gayatri, AMLA. Please unmute your mic and speak.
Unmute.
Good evening, respected Principal Ma'am, HOD Sir of Department Mathematics, HOD Sir Department of AML, and other faculty members who are involved in this workshop. Firstly, I would like to introduce myself, Gayatri from AML A section. By conducting this workshop, we learned new things and faculty members are explained very well. During this workshop, we learned how mathematics is applied in many fields such as engineering, science, technology, economics, medicine, and data analysis. Concepts like calculus, statistics, and algebra play an important role in solving real world problems. This session by expert speakers made learning interesting and practical. This workshop is very useful for first year BTech students to know about importance of mathematics in our life. So I request Principal Ma'am and HOD Sir of Department Mathematics to conduct workshops like this in future also. Thanks for giving this opportunity. Share my opinion about this workshop. Thank you all.
Definitely, we will think on it.
Thank you, Gayatri. Next one, serial number 19, KS Nihantalakshmi, AMLA. KS Nihantalakshmi, AMLA, please unmute your mic and speak.
Good evening, Ananda. Myself Nihanta from AML A section. I am very happy to express my gratitude of the International Day workshop. It is very helpful to us, which is conducted by our department of Bapatla Engineering College. The research persons who explain the topics every day in an informative and smooth way, and I learned many things, and the research persons also teach the topic in starting from basics to the higher level, which is useful for our higher studies and for the competitive exams. We learn many things, and I also learned what is the importance of mathematics in the role of technology and in our daily life. Thank you for giving this opportunity.
Thank you, Nihantalakshmi. Next one, serial number 20, D. Manoj Kumar, Cyber Security. D. Manoj Kumar, Cyber Security, please unmute your mic and speak.
Good evening, everyone. Respected faculty of the Department of Mathematics, respected guests, and my dear friends. I'm truly honored to be a part of this international workshop. I want to express my sincere thanks for this privilege of attending this international workshop. These sessions were truly enlightening and have given me, and I'm sure many of us have much clear understanding how mathematics drive engineering and technology forward in today's world. I would like to convey my heartfelt gratitude to the expert speakers for generous sharing their knowledge and experience in the presenting concepts in such a clear and engaging way. I sincerely thanks the honor coordinators and everyone behind the scenes for their dedication, smooth arrangements, and support throughout this event. In this in this international workshop, I was motivated to learn further and drive this concept use in daily life and use it for the future projects. Thank you once again for inspiring and immense valuable experience. Thank you for everyone.
Thank you, Manoj Kumar. Last speaker, I am repeating again, serial number 9, K. Bhanuchandar, CSCB. Serial number 9, K. Bhanuchandar, CSCB.
Good evening,
please
sir.
Unmute you. Okay, speak.
Good evening, all faculty members and research persons. My name is K. Bonichandar and I am studying first year CSCB section at Bapatla Engineering College. The Department of Mathematics conducted a one-week online international workshop on mathematics, bridging ideas and innovations. Through this workshop, I learned many mathematical concepts and how to apply them to problem solving. This session was very important and extremely useful for my future studies. Thank you so much for giving this me wonderful opportunity. Thank you, sir.
Sir, please unmute your audio, sir.
Okay, thank you, Bhanuchandar. Okay. Thank you, Ananda, for your good response and valuable support. Expecting the same cooperation for the remaining sessions also. Okay, before going to conclude the session with vote of thanks, let me remind you something. Today we are going to share two feedback forms. One is for day 6, another one is overall workshop feedback. All of you, it is important to fill both the feedback forms immediately after sharing. Okay. Also, if any feedback form, if you are not filled previously, try to fill all those feedbacks. Complete all the feedbacks today itself. Today we are going to share two feedback forms. One is for day 6, another one is overall feedback. Kindly fill it after sharing immediately. Okay. Today's session concludes with vote of thanks by staff coordinator Sri I. Pothras Garu.
Sir,
please.
Vijay Sardi Garu, so I'm Ramlingeshwar speaking. Just I want to share few words from my side.
Yes, sir. Please, sir.
Please, sir.
Yeah, so, sir, I want to, share something to the students also, this college. So, first of all, I'm very thankful to you, Vijay Sardi Garu. So, you have pushed the things from the past 2 months from your side. So, keep on reminding the things. So, I'm grateful to you. And
Thank you.
yeah, so Professor Narsum, I'm thankful to you so for giving me this opportunity, and so I'm also thankful to Balay Garu, then so Pothraj Garu, then Anita Madam, and Fatima Madam, and other respected faculty. So another thing is I want to say a few words about, and this is not an easy thing conducting 1 week workshop at this moment because no IIT, no university is conducting such kind of workshops during Ramanujan birthday. So simply they will celebrate for some time and then they'll leave it. Okay, this is, I'm highly appreciating all you faculty members, HOD, and who are behind this program, all the coordinators. This is a very great thing, continuing this Ramanujan birthday celebrations yearly with lots of efforts. So no other university is doing like this in the current situation. So that is what I want to say. And for the students, I want to say Bapatla Engineering College is not a small institution. See, many leaders are there across the globe from this institution. So I will say one thing to you, all you youngsters. In 2001, so I was there for PG diploma course in BEC after my MSc course. You will believe it or not, in 2001 to 2, so in GATE examination, in 2002, I think, in 2002, 300 people qualified in GATE examination, and which was a record from entire India. That is from BEC. That is the, extraordinary achievement from BEC. So students are very good at that time, but I am not sure how the people are studying now. So focus on your goals, focus on your, higher studies, and have good goals and learn all the tools required for the industry. And so that's all. Follow your teachers, do some publications in the final year, and get good jobs. That is what I want to say. Thanks, Vijay Sardigar and Professor Narasimha.
Sir, thank you, sir. Actually, we feel that it is a best homage to a world greatest mathematician, sir.
Yes.
So we are actually paying our homage through a 1 week international workshop with the help of eminent personalities like you. Once again, thank you very much, sir.
Thank you, sir.
Thank you, sir, Ramlingeshwar Garu, for your nice inputs to the students and faculty and our college.
Yes, thank you, sir.
Okay. Today's session concludes with vote of thanks by staff coordinator Sri I. Pothras Garu. Dear students, don't remember to fill the feedback forms for day 6 and overall feedback and the previous feedbacks, if any. Pothras Garu, please.
Respected Principal Dr. N. Ramadevi Madam, our beloved HOD Dr. K.V. Nacharala Garu, Honorable Resource Persons, my dear fellow faculty members and participants, good evening to all. It's my privilege to propose the vote of thanks to all who have who have helped us in making this workshop such a resounding success. First of all, I would like to express my sincere thanks to our management and principal madam for their encouragement and providing us all the necessary facilities for conducting this workshop smoothly and successfully. I would also like to thank our beloved head of the department, Dr. Kevin Acharya Garu, for his constant support and valuable guidance throughout this workshop. I would like to thank our distinguished resource persons, Dr. K. Lavanya Madam, Dr. L. Jagannathan Garu, Dr. M.A.S. Srinivas Garu, Dr. N.V.R.D. Kumar Garu, Dr. P. Nagarani Madam, Dr. T. Ramlingleshwarao Garu for giving excellent presentations and making this workshop so interesting and meaningful. I am happy to express my sincere thanks to our faculty members who have made this workshop a grand success with their cooperation in all the aspects. I would also like to thank Dr. K. Mandeep Garu, HOD Department of AML, Sri N. Kiran Kumar Garu, MCA HOD, and Sri P. Koteswarao Garu, Faculty of MCA Department, Institutions Innovation Council IIC President Dr. Nazir Sheikh Garu, Vice President Sri M. Lenin Babu Garu, Faculty of EC Department, Institutions Innovation Council IIC members, and Sri U. Venugopal Garu, who are sincerely extending their technical support to us in conducting this international workshop. Last but not least, I think all the participants who have turned up in such a great number from different institutions across the country for attending this workshop. Thank you, one and all.
Thank you, Godarazu. Small information to students. Don't leave the group because you are going to get communication and certificates, other things from now onwards. So still you receive the certificates and the information. Don't leave the group. If you once you fill the feedback forms completely, you will automatically get the certificate. Please fill all the feedback forms and overall feedback form. Okay. Thank you one and all for your great support. We are going to share it in the group.
Thank you, sir.
Ramu, thank you, Ramu.
Sir, Acharya Garu.
Thank you, Narasimha. I'm leaving. Yeah, thanks.
Sir?
Yeah. Thank you, sir. I'm leaving. I'm dropping off. Yeah.
Sir?
Sir, please.
Sir, we can close, sir.
Yes, sir.
Okay. Thank you. Recording